Okay, so we can see here that this has pretty much the same or similar endpoints to f of x equals x to the third. It's going up and to the right and down and to the left. Oh, bless you. Okay, so if n is odd, which means if you have if you look at just that lead exponent, if that lead exponent is odd and the coefficient is positive, then you know that these two are going to be your endpoints. Because you know this is similar to f of x equals x to the third power. Okay. So it's the same thing if you have, let's say you have your graph, you have your x, and you have your f of x. Now let's say this one goes up and to the left and down and to the right. And again, in between here can look like anything at all. We have no clue what in between is going to look like. But for the endpoints, we see that for this one, we know that f of x approaches infinity as x approaches negative infinity. And for this endpoint, I'll draw a little arrow up there. And for this one, f of x approaches negative infinity as x approaches infinity. Okay. So if you look at it, remember that's really similar to negative x to the third power. So that's saying if n is odd and your lead coefficient is less than 0. So with this one, you'd have to have a positive lead coefficient. And for this one, we'd have to have a negative lead coefficient. But remember, this is similar to f of x equals negative x to the third. You have your odd exponent and a negative coefficient. Here, you have an odd exponent and a positive coefficient. So it would be the same endpoints if it had 1, 2, 3, 4, 5, whatever coefficient as long as it's positive. Okay, so let's say if we had, move that up a little bit. Oh, I'm still writing. I'll leave that up there for a few seconds before I move up.
Are you thinking they're gonna be on the test on Monday too?
Oh no, this is all on exam 2. Just whatever we went on last class and before will be on this test. Okay, so let's say if we had the graph that's your x, and this is your y. And let's say this endpoint went up and to the right, and this endpoint went up and to the left. Okay. And again, the middle could look like anything. We have no idea, but we're not looking at that just yet. Okay, so we know if this is going up and to the right, we know that f of x is approaching infinity as x is getting bigger, or as x approaches infinity. And for this one, your f of x is getting bigger as x is going towards negative infinity. Approaches infinity as x approaches negative infinity. Okay. Now, if you notice, this looks pretty close to our x squared. Remember, our x squared is the same thing, going up and to the right and up and to the left. So that means that if your exponent is even, and your lead coefficient is positive, that's when you'll have those two. Okay, so that's similar to f of x equals x squared. You have an even exponent and a positive coefficient. Okay, same thing if you multiply by -1. Oh, let me put f of x equals x squared. Well, don't have to put it there. So for this one, let's say you have your x and your f of x there. Let's say these endpoints go down and to the left and down and to the right. Kind of curve that a little. Like I said, in between there could be any and everything. We have no idea. As long as there are no sharp corners or missing sections, we know it's a polynomial. Okay, so this side, we know that f of x approaches negative infinity as x gets bigger. And for this endpoint, we know that f of x also approaches negative infinity, but as x gets smaller. Let me move that down a little bit. There we go. Okay. So if you notice, that's just like negative x squared. It's opening downward. So if it's opening downward, you have the same thing. So we know that if your lead exponent is even and your lead coefficient is negative, then those are the two endpoints you'll have. And this is similar to f of x equals negative x squared. Okay. So if you can remember how those four graphs look, it'll make these type of problems really a lot easier. All right, so I'll leave that up for a few seconds. We'll do a few examples. Excuse me. Yep. Okay, so let's say for our first example, we want to determine the endpoint behavior of the function f of x equals, let's say, 0.2, say x minus 2, x plus 1, and x minus 5. Well, it wouldn't matter anyway. Okay. Now with this one, you don't have to FOIL and then distribute and all of that to find out what degree it is. All you have to do is remember, if you have 0.2 x, y, z, then that would just equal 0.2 times x to the first power times y to the first power times z to the first power. Okay, so you know this would be a degree of 3. Okay, same thing here. If you have f of x equals 0.2 times x minus 2 to the first power times x plus 1 to the first power times x minus 5 to the first power, that's still going to be a degree of 3. Okay. So if it has a degree of 3, one thing we know is that our n is odd. Okay, so we have that part figured out. Okay. Also, we can look right there. Even though it's just 0.2, our lead coefficient is positive. So lead coefficient is positive. Because remember, this is your A sub n. Okay, so you have a positive lead coefficient and n is odd. So if you think back, now let me write that out. So if n is odd and our lead coefficient is greater than 0, that sounds like x to the third power. Positive lead coefficient, odd exponent, similar to x to the third power. Okay. So what I would do is normally right next to it, just make a quick little sketch of x to the third power because it looks kind of like that. So you know this graph, since it has everything that x to the third power has, is going to go up and to the right and down and to the left. Okay. So we know the function goes up and to the right. That's just a fancy way of saying f of x approaches infinity as x approaches infinity. And we know that the function goes down and to the left. Which is just a fancy way of saying f of x approaches negative infinity as x approaches negative infinity. Okay, so those would be your two endpoint behaviors. Okay, so all you have to do is find out the degree and the lead coefficient and just match it up to either x squared, negative x squared, x to the third, or negative x to the third. And it'll have the exact same endpoints. Does that make sense? All right. Leave that up for a few more seconds. Right. So let's say for our next example, if we wanted to determine the end behavior, for f of x equals x minus 3 times x squared plus 5x minus 1. So again, first thing you want to do is find out the degree. Yep, this one's degree 3. So if you have f of x equals x minus 3, remember that's just x minus 3 to the first power. And x squared plus 5x minus 1, this itself is just degree 2. Yep, but your lead coefficient is squared. Yeah. So if we did factor that one out, you'd have 3 factors. So this one is just degree 1. Okay, they're all just one term, so that entire term is degree 3.
And is odd.
Yep, so we know that n is odd. Okay, now here, we also know that if there's nothing there, you just assume it's a 1. Okay, so you can make that equal to 1. Okay, so we know our lead coefficient is positive.
Is it just one or one?
Oh, just 1. I don't think I erased that equal sign as well as I should have. Okay, so we know that n, let me give that a little more room. N is odd, and we know our lead coefficient, that should have been a smaller n. Our lead coefficient is positive. And again, that's similar to x to the third power, just kind of written a different way. So this is similar to x to the third power, where if you draw a little graph of x to the third power, kind of looks like that. So we know it goes. Oh, do you have a question? Oh, I thought you had a question. Up and to the right, which means that f of x approaches infinity as x approaches infinity. And we also know this endpoint goes down and to the left. I don't know why I put a U there instead of a W. Okay, so since it goes down and to the left, that just means that f of x approaches negative infinity as x approaches negative infinity. Forgot my negative. Okay, so those are the endpoint directions. Oh, endpoint behavior. Okay, any questions on that one? All right, I'll leave that up for a few seconds. We'll do one more example. Oh, 2 more. All right, looks like everybody's okay. So let's say if you wanted to determine the end behavior for f of x equals negative 5x. Ladies, if you're going to whisper, you could please take that out in the hall. Thank you. Say 2x plus 1 times x plus 9 times x minus 3. Yep, this one would be a degree of 4. Because if you have f of x equals negative 5, that x is x to the first power times 2x plus 1 to the first power times x plus 9 to the first power times x minus 3 to the first power. So all of those will give you a degree of 4. Yep, so you know that n is even. And if we look at our lead coefficient, Yep, it's negative. So our lead coefficient is less than 0. Okay, which is our lead coefficient. Okay, so that means n is even, and our lead coefficient is negative. Yep, that's really similar to negative x squared. Let me clean that up a little bit. N is less than 0, which is negative. Okay, so it's really similar to negative x squared.
So it goes down?
Yep, it goes down both ways. If you remember, negative x squared just looks, I'll put it underneath it, kind of like that. Okay, so you know it goes down to the right and down to the left. Okay, so you know it goes down and to the right. That's just saying f of x approaches negative infinity as x approaches negative infinity. I mean, down and to the right as x approaches infinity. And if it's going down and to the left, down and to the left, okay, that means our f of x is approaching negative infinity as x approaches negative infinity. Oh, move that up. Okay, so those are your two endpoint behaviors. All right, any questions on that one? All right, leave that up for a few seconds. Oops. Right, so let's say for our, a few people still writing. Let me leave it up a few more seconds. All right, so let's say for our next example, if you wanted to determine the end behavior for, say, f of x equals negative 3x times 4x to the third minus 1 times 7x squared plus 1 times x plus 1. Yep, degree 7. Okay, so first we know our, if we had negative 3 times x, you can write that as x to the first power times 4x to the third minus 1. The lead coefficient in that one is 3. So this is degree 3. Okay, so this one's degree 1. If you have 7x squared plus 1, yep, that's degree 2. And this is just degree 1. Okay. Remember, these aren't added or subtracted, so they're not separate terms. This is all just one term. So you have 1 plus 3 plus 2 plus 1. So you have a degree of 7.
That is odd.
Yep, so we know that n is odd.
And the coefficient is -8. So
Yeah.
it's less than 0.
Okay, so your lead coefficient is negative. So we know that a sub n is less than 0.
So it looks like x, negative x to the third power.
Yep, negative x to the third power. So when n is odd, and your lead coefficient is less than 0, that's similar to negative x to the third power. Okay, so we know that negative x to the third power, if x to the third looks like that, then negative x to the third just flips it. So it looks like that. Okay, so even if you can't remember how negative x to the third look, if you remember x squared and x to the third, you can always just flip them over. Okay, so remember this is x to the third, and this is negative x to the third. Okay, so that means it's going up and to the left. Okay, or in other words, f of x is approaching infinity as x approaches negative infinity. And we also know it's going down and to the right. So that means f of x is approaching negative infinity. As x is approaching infinity. Okay, so those two would be your endpoint behaviors. All right, any questions on that one? All right. Leave that up for a few more seconds. Okay, so now we're going to do a quick review of intercepts. Well, don't know why I made that look like two separate words. Okay, remember your x-intercept is just where it crosses the x-axis, and your y-intercept is where it crosses the y-axis. Points that cross the x-axis, or you can make y equals 0, and y-intercepts are points that cross the y-axis. Or where x is equal to 0. And that's going to shut off in about 30 seconds.